So let us start with the remaining objects which we have left out on the other day. So the other day we have talked about the tables, then we have seen what could be a view and all, and we talked about the sequences also. So and we stopped at the point where we need to look at indexes. So let us proceed with the indexes, and once we complete the theory part, then we will go with practicals. So hope everybody can able to see the slide. So is there anyone who would not be able to see that? Okay. So starting with the point, what could be an index? So basically, index is uh, useful, especially from Oracle points of view. Index is useful in faster retrieving of the data. So that is what the basic need of an index. So when you have more and more rows in the table, then usually what happens is when you want to retrieve the data from the table, automatically the accessing will be slow. But if you create an index, that will improve the fastness of that particular table retrieving or data retrieving and all. Now, how index is going to work is in the same fashion like how an index for a book will work. So every book will have an index listed in the beginning, and index is nothing but the book index is going to specify a particular topic and its page number. And if you want to go to a particular topic, what you would be doing is you would be referring to index, and using the topic or against to the topic, some page number will be mentioned in the index, and directly you will jump to the page number. So suppose you have a topic like Oracle database, and which is residing in page number 590. So what you can do is you can directly jump to that page number 590 instead of scanning starting from page 1, page 2, page 3, etc. So that is how basically the index is going to make the retrieving faster. And here are some points that we need to understand about the index. So starting with the first one, index is a schema object, and index is used by Oracle database in order to speed up the retrieval of rows by using a pointer kind of thing, and it will reduce the disk IO by using a rapid path access method to locate the data quickly. So just like how book index is going to help you to reduce the effort, here also the effort will be reduced by faster access, and that effort we are going to call it as IO. Now what is this IO? What happens if more IO is there? So these points we will be discussing in DB architecture. So that's the reason I am not stressing much on this. And index is independent of the table. So that means even you can have if you can drop your indexes without dropping a table. You have that independency. You don't require to be dependent on the table. And it is used and maintained automatically by Oracle server. So the moment you create the index, Oracle will make use of that index automatically, and also the maintenance of the index also will be taken care by Oracle. So now what I mean to say by maintenance of index, like whenever you update a row in the table, even index also should get updated. Or if you insert 1 lakh rows into your table, automatically index also should get updated with those 1 lakhs. So something like suppose you are adding a new concept or new topic to the book, then what happens, automatically your index also should get updated. So say similar way, even when we do some modifications to the table, index also will get updated, and this will be done automatically by Oracle. We don't require to do any manual activities. So any queries over there? Okay. So the next thing is how the indexes would be created. Now there are two ways how the index will be created. The first one is automatic creation of index, and the second one is manual creation of index. Now as you can see on the slide, when the automatic index will be created is whenever you declare a column as a primary key, or whenever you declare a column as unique key in the table definition, then automatically Oracle will create index. So either you declare a column as a primary key or you declare it as a unique key. In both the cases, index will be created on a table automatically. And when it comes to manual things, suppose you have some columns which are not primary keys or which are not unique key, then you can go and create indexes manually. So these are the two ways that we need to have or we are having in order to create an index. Now here I would like to ask one question. How many primary keys can be there on a table? So please answer this. So if I have a table, for that table how many primary keys I can create? No one is having idea? Okay. So we got one answer stating that only one primary key column is possible or one primary key is possible. So anybody conflicting with that answer? Okay, fine. So yes, only one primary key is possible for a table. So we don't have the option to have multiple primary keys on a table. And how many unique keys will be possible? Or I mean to say how many unique key columns can be declared? Yes, exactly. So we can have more than one unique key columns. I mean to say you can create n number in fact. So there is no restriction. You can create n number of unique key columns, but always the primary key will be only one. So that is how we have those things. Now how you are going to create an index? So the syntax would be create index name on which table you want to create, and in the bracket you need to specify the column name. For example, you can see the example in the below portion of the slide. There was an index by the name emp last name underscore idx on the employees table, and on which column we are creating index is based on last underscore name. Now here one more point I would like to specify, or I would like to ask a question. Now when I have a column declared as primary key, what should be the data type of that column? Or let me put in another way. Should I declare number data type columns only as primary key, or can I declare even character data type columns also as primary key? Okay, we have better number, but my query is it possible? Is it possible to create a primary key on character also? Character or date, any data type. or primary key allows only a number. So what is your guess? Yes, exactly. So it is not only numbers, we can take any data type and we can declare it as primary key. Provided the that particular column or that particular data type should satisfy the primary key conditions. So what the primary key says, the values should not get repeated, so and not null. So these two, if that was satisfied by a date data type, you can declare that date data type as primary key. Or if this has been satisfied by characters, even you can declare a character as a primary key. So why I am discussing this point, because there is a misconception in real time saying that primary key will always perform faster on numbers. So usually people says, if you create a primary key on a character data type, it will run slow, and if you create a primary key on a number, it will run fast. So frankly, there is nothing like that. For Oracle, every data type would be same, or accessing the data would be same. So it is not something like number means it will retrieve faster, or character means it will retrieve slower. So it's not like that. It's just a misconception that is going in the real-time market. So I just want to clarify that point. And these are very important guidelines that you need to remember whenever you are going to create an index. So you have two things: when you need to create an index and when you should not create an index. So starting with the first thing, a column which contains a wide range of values. So when I say wide range of values, what I mean to say is more number of unique values. Suppose if you take gender column, number of unique values under gender column will be only 2, either male or female. So for those kind of columns, you should not create any index. So as per the first point you can read on the slide, a column which contains wide range of values. That means huge number of unique values are there, then that column should be considered for creating an index. For example, employee number, because one employee number will not be equals to another employee number, and it will be unique. So we can consider employee number as the column to create the index. So, or we can create an index on top of that. Now, suppose I have a table, EMB table, under which department number column is there. Now, can you people tell whether we should go and create index on department number or not? Yes. So on department number, we don't require, we can create an index. Possibility is there, but we should not create an index. Why? Because hardly you will be having 20 departments or 30 departments, which is very less value. So that is the reason in those kind of columns, we don't require index to be created. So that's the reason we don't require to create an index. So that is the point. And coming to the second point on the slide, you need to create an index when a column contains a large number of null values. So suppose you have 10,000 rows, but out of 10,000 rows in a particular column, you have only 2,000 actual values and 8,000 null values are there. So when you have null values more than what the actual values are, then it is better to create an index on top of that particular column to improve the performance. Because when you create an index, Oracle will ignore those null values and it will create index based on only those actual values which are available. So while retrieving, it will be very fast. And so is it clear, or any queries are there before we proceed for the next point? Okay. So the next point is, again, you need to create an index on one or more columns which are frequently used together in a where condition or a join condition. So this is very important point. Once again, we will be seeing this point in performance tuning, and we will be discussing more during that time. So as per the point, what it says is, suppose you have a select query with some where condition. In where condition, what are all the columns specified? On top of those columns, you need to create an index. Suppose I have a select query like this: select star from EMP where department number equals to 10. So in this case, I should have an index on that particular column called department number equals to 10. And I am retrieving employee number from EMP table, but and I am using DEPT number in where condition. But if I don't have index on DEPT number, then it may lead to performance issues. So that is one more point. And the next one says, we need to create an index when the table is very large and the most of the queries are expected to retrieve less than 2 to 4% of the rows. So what we mean to say by that? For example, I have a table with 10 lakh records, and you know that out of 10 lakh records, every time you would be retrieving only 4,000 rows. So out of 10 lakhs, if every time you would be retrieving maximum of 4,000 rows, then it is better to create an index, and so that the retrieving will be faster. So that is what it says. If the table size is very large and you are retrieving only 2% to 4% of the rows from the table, then it is expected that you need to create an index in order to improve the performance. And coming to the third point, once again I am repeating the third point. So let me show you that live. Okay, so hope you people can able to see the screen what I am sharing. So please confirm. If somebody is not able to see that, please confirm. So I am connecting to a database using Scott and Tiger. And as per the third point, for example, I am writing down a query like this. Okay, so then what happens is, normally on EMP table, index will be created on EMP number, but here in the where condition you are using DEPT number. So in this case, even though index is there, Oracle will not use that index. Why? Because Oracle will use index only when you create index on DEPT number. So as per the third point, what it says is, the column which is mentioned in where condition or after where condition should have index created. So if you don't have index on the column which is mentioned after where condition, then Oracle will not use index, and the performance may go bad. So is that point clear, Pallavi?
Pawan, I have a doubt.
Yeah, Junaid.
Yeah, I mean, I think in the second point, like you said, if it is not having more values in a particular column, we should not be doing an index. I believe in the EMP table there won't be like maybe there would be like 4 or 5 values for department number. So should we still go ahead and create index on department number?
Yes, yes.
Though it doesn't contain a wide range of values like from the first point.
Yeah. Even if doesn't contain a wide range of values, what I'm trying to say here is, suppose every time you are using this select query, so what the select query I have written, if you keep on using this select query, then we need to go and create index on top of this. So don't worry about these points. Okay, so these points once again will be repeated in performance tuning. So you would be understanding more, because I can show you practically during that time. So here I can't show you practicals now. I mean to say I can generate some trace and I can show you during that time. Now if I generate some trace and I show you, you people would not be able to understand anything. Okay, so we have a question from Pallavi. Yeah, so if we have two columns in the where condition, suppose like this. So we have two columns, one is DEPT number equals to 10 and salary is greater than 10,000. Now in this case, on which column we should create index? Should we create on DEPT number or should we create on salary table? Sorry, salary column. Frankly, at this point of time, you can create something called composite index. So I am just showing you the syntax how the composite index will be. So this is how the composite index will be. The syntax would be same. Only difference is in the bracket, instead of one column you would be giving two columns. Then what Oracle will do is, combining both these columns, it will create one index, and we call generally it as the composite index. Okay, so if it is employee ID instead of salary, then on employee ID already index will be there, so we don't require to create an index. Only thing is we need to create index on DEPT number. So suppose your query is like this. So in this case, you need to just create index on DEPT number. You don't require to create index on EMP number, because already on EMP number separate index is available. Then what this query will do is, this query will make use of two indexes. It will use index on DEPT number and also it will use index on EMP number also. So is my point clear? Okay. So let us go back to this once again. So now let us go and see the scenarios when we should not create an index. So like almost the points are reverse of what the points we saw above. The first one says the columns which are not often used in the where condition, we should not create index on top of that. For example, in where condition, if you are using suppose very rarely you are using one particular column, in that case you should not go and create an index. Suppose let's say daily I will be using this select query with these two things. Okay, department number equals to 10 and salary is greater than 10,000. But let's say once in a while or maybe once in a week, I will use this condition. So now the first query is a frequently used query. That means almost every half an hour you would be executing that and all. And the second query, let's say you are using once in a week. Now, because you are using once in a week, you should not go and create an index. So what Oracle says is, the columns which are frequently used in the where condition, you need to create index on only those columns. You should not, even though in the second query you are using location in the where condition, but still you should not create index because that query is used very rarely. So got this point? And the second point is reverse of what we have seen above. If the table is small or the queries are retrieving more than 2% to 4%, those from the table, then we should not create an index. Suppose your table total count is 20 rows, and out of 20 rows, if you are retrieving 10 rows, that means you are retrieving 50% of the rows. So if you are doing 50% of the row selection, you don't require to create an index on top of that. And also the next point is very important. If the table is getting updated very frequently, then also you should not create an index. Why? Because the moment the table is keep on getting updated, index also will get updated, and that will lead to performance issues. So that's the reason it is better to avoid creating index on frequently updated tables. And also last and finally, if the indexed columns are part of an expression, like when I say expression, you are including that in some group functions, then then also you should not create an index. So these are the guidelines that we need to follow strictly. So then we have a command on how to drop an index. So we need to just say drop index name. And as we discussed earlier, index is independent of table. So even if you drop the index, it doesn't have any impact on the the table. And more things, as I said about index, we will be learning in DBA course in performance tuning. So there we will be learning about how many types of indexes are there, and in which scenarios we need to use which type of index. So we will be discussing all those points. So the next object we have is synonym. So basically synonym is nothing but an alias name to the existing object or existing table. So the name itself is telling you synonym means a alias name. So here you can see a synonym by the name d underscore sum was created for a particular view called dept underscore sum underscore bu. And how you are going to drop the synonym? You have a simple command, drop synonym name. Now, what you think is the purpose of having a synonym? When we have object name or table name directly, why I need to create a synonym?
If you want to hide the original table name from the other users.
Yes, exactly. So if we want to hide the table name from the end user, then we would be creating these synonyms. So it's basically for security reasons that we would be creating the synonyms. More than that, there is no other purpose or there is no other reason. It may not be exactly Pallavi that we need to create because our table name is long. Sometimes it may happen, whatever you said, if our table name is too long, we can create a synonym for that with a very short name, but not always. So the main purpose of synonym is to provide the security. Yes, yes, exactly. In real time, it will be as per the company's rules or as per the requirement and all. So even, for example, security. So what I'm trying to say is, table name should not be visible to the user. Now, if you have a database functioning for a normal client, then every table name can be open to the user. There will be no restrictions. But for example, if you are using some defense database or some tables related to defense or tables related to some military things or tables related to any financial sector database. So in these situations, security is more important. So in those cases, you would be creating the synonyms. And yes, as you said, the name of the tables will be decided based on the business requirement. So that is how we have the things. Now let us go and see how we are going to create the table and how we are going to insert the data. So we will see all those things. So any queries before we proceed? Okay, fine. So I am just creating one table, and then we will add one constraint to those tables, and we will proceed with creating the index, creating the synonym, all those things. Okay. Yeah, by tomorrow your server access will be ready, Pallavi. Lab admin is working on that. They are preparing the new machines for you. It will be ready by tomorrow, and you will get an email also how you can access the servers. Detailed email will be sent to you, and you can go through just you need to just follow the steps what is there in the email, and you can able to access it. So I am creating the tables which we discussed on the other day. So starting with student ID, we have checked this as a number, and then not null. Then we have student name or student first name, we can say. So we have first name with varchar 2 of somewhere around 20. Then age, okay, not age. I would be taking date of birth, which is a data type. Then gender, character of 1. So of course we can take lot much information, but I'm just taking only this information. Let's go and see. So now that the table has got created, okay. So now what I would be doing is I will be adding the constraints to these columns. So for example, I will make the first name as not null and then date of birth as not null, then gender as not null. So using alter table command and see how I am going to do that. So you people might be knowing these commands and all, but still just for the reference that I am going to give this. So I am making first name as not null. Oh, sorry. To see first name, then varchar 2 of 20, then not null. Oops. Typo error?
Spelling is first name.
Yeah.
Yeah, type of first name.
Got it. I'm just going with typo errors. Fine. So now I have even the first name as not null. Now in a similar way, let me make date of birth as also not null, and then gender also as not null. So this is how we are going to do the things. Okay. Okay, we have some question. Okay. Sanjay, you would be getting Linux only for practice. Windows also you can practice it, but in real time what we use is Linux flavor most. So databases on Windows operating system is very rare case. So that's the reason even our entire course will go through, wherever required I will be giving the idea about how the things will work on Windows. But most of the times we would be seeing Linux only. And about your question, Pallavi, this is a putty session. This is a tool called putty. So here if you want to copy and paste, what you would be doing is select the content using left click of the mouse, and just you need to do right click of the mouse. So nothing else. This is easiest way to copy. Of course, for your SQL practice and all, you might not be using putty, but you would be using, that SQL plus white color window, or SQL developer. There is a tool called SQL developer, so you would be using that one. And putty you would start using when we start with Unix classes. So probably Monday or Tuesday. So now we have made some changes to the columns. Now let us add few more columns. So this is the command on how to modify a column, but similarly we can go and add a column also. So let us go and see how we can add a column and all. So we need to say alter table name, add, and in bracket you need to write down the names, name of the column, and then the data type. So for example, I am saying father name and mother name. So, and now if you describe it, you will be seeing even the other two columns which you have added just now. So this is how we are going to do the modification or addition. And also it is possible to increase the or to modify and increase or decrease the size of data type. For example, let's say student ID I want to reduce from number 5 to number 4 or number 3. Yes, definitely I can do that with the help of like this. So now you can see, so this was declared as number 3. I didn't get you, Sanjay. What you mean to say that? Before adding anyone, use alter command. Okay, yeah. Do you mean to say like before we do any activity, sorry, we do any modifications, do we need to use alter command or not? So are you asking that question? Okay, fine. Yes, if you want to do the modification for the existing columns, or you want to add new columns, or you want to drop one column, so for all these activities, you are going to use alter command. Because basically you are, by adding a column or dropping a column or modifying, you are just making the changes to the table. So that's the reason we will be using the alter table command. So let's go for the next one. So let us go and see how we can add the constraint. So we have student ID. Let us make the student ID as the primary key. So this is the syntax in making it as a primary key. So we need to say alter table name, add constraint, and here we need to provide the name of the constraint. You can take any name, but here I am taking some meaningful name like pk underscore student underscore id. That means pk stands for primary key and student id is the column name. And then we need to write down the clause which constraint it is. Is it primary key or is it foreign key and all. And then in bracket we need to specify on which column we need to add the constraint. So like that we are going to add the constraint. Even for the foreign key also we are going to use the similar syntax. Okay, no Pallavi, we can't do that. If we have an index already on a column, we can't make it as primary key. But if you create a primary key, automatically Oracle will create an index. So it's vice versa is not possible. So then let us go and insert some data into this table. So for that you are going to use DML commands starting with insert. So you are going to write down insert into the table. Then you will be saying values, and in bracket you need to provide all the details. So let me do one thing. So now I am going to write down the insert command. So this is the syntax we need to follow. In bracket we need to start writing down the values for all the columns. For example, first one student ID. So let's say starting with 100, then first name. Now whenever you are going to insert the characters or a data type values, then you need to include them in the single quote while insertion. For example, if I want to make or if I want to insert the first name as Mark, I should not write simply like Mark, but rather I should go and include that in a single quote. So that is the format that we are going to follow. And middle name, if you wish you can give middle name, or otherwise just leave it. Even last name also, because those columns we are declaring it as not null values. And even surname, so I am not taking, let me take null values over there. So if you want to insert null value in those columns, you can declare like this: null comma null comma null. That means middle name, last name and surname, all the three I want it as null. Then we have date of birth. So let us take date of birth as 1st Jan 1990, and gender, so we need to say M for example. And then father name, so you can specify some father name like John. And mother name you can go for Lucy. So this is how we are going to write down one insert statement. And the moment you do that, a row will be created for you. But what happens here is, the row will be created or the data will be inserted into the database, but if you want to make this data permanent to your table, then we need to use transaction control language. So one of the transaction control language options is commit. So we need to use that particular command, and this command will make the changes or the data insertion permanent to the database. So until unless you don't give commit, Oracle will not allow you to make those changes permanent. So this is the case. And this is when you want to insert all the data inside a table. And we have another way also. If we want to insert into specific rows, or sorry, specific columns, then you can write down like this. Suppose I want to insert the student ID, the first name. I don't want to insert middle name, last name, surname and all. Then I want to insert date of birth and gender. And even I don't want mother name or father name. Then, in bracket we need to specify all these things. Let's say employee ID is 101. Then we have name. Okay, first name. Then directly we need to give the date of birth. So I am taking it as 25th June 1993, and then the gender. So gender, let's say F. So this is how we are going to insert the things. So here what we are doing is, we are not inserting to all the columns of the table, rather we are going to insert only into specific columns of the table. So the first insert command is going to insert into all the columns. The second insert command is going to insert into specific columns. And answering your question, Pallavi, we don't have the option. We can't insert more than one row at a time with different values. So that's not possible through insert command. Just a minute guys, I'm getting a call. Yeah, so sorry, I just got a call from office. Yeah, we can't insert more than one row. That's what I already said. Okay. Can we update? Yes, you can update more than one row. That's possible. So even delete is also possible. You can delete more than one row at a time, and you can update also. Only thing is, while insertion, you can't have multiple rows insertion at the same time. So that is the how we are going to do the insertion. Suppose after doing this, if I don't want to have this change, I can just simply say roll back, so that this insertion will not be done. But one important thing is, after you give commit, rollback will not work. So even though here it may say that rollback is completed, but actually rollback will not be done. So once you commit, the data will be permanent and you cannot do a rollback. So that is the option. And if we want to delete all the rows, simply we need to say delete from the table name. Then it will delete all the rows. So if we want to delete a specific row, then we need to say delete from so and so table, where for example student ID equals to 100. So I am deleting only one row or a specific row. So this is how we are going to do it. And even the case is the same with update. So we can say update update the table name and set father name is equals to John. So if we do this, it is going to apply for all the rows. But if we want to again do this for a specific row, we need to just copy this, and at the end we need to write one where condition. For example, where student type will be equals to this one. So only one row will get updated. So these are the basic DML commands that we are going to run through. So now let us go and create an index on top of this. So already earlier what we have done here is we have made the student ID as a primary key. So automatically internally Oracle might have created one index for our purpose. But still, if I want to go and create another index for other columns, I can still do that. So for example, I am going to create an index on date of birth, let's say. So what I can do is create index name. So you can take any name for the index, there is no restriction, on the table name, and in bracket I need to declare my column name. So this is how we are going to create an index. And if we want to drop an index, we need to simply say drop index name. And now we have two rows in the table. If we want to delete all the rows from the table, then we have two options. Earlier I showed you one delete statement. So for example, this is the one. So this will delete all the rows from the table. And similarly, you have a command called truncate table name. So this will also delete all the rows from the table. So even delete from the table name will also delete all the rows. Even truncate table also will delete all the rows from the table. So in interviews, they will ask you a question, what is the difference between running delete from table name command or the truncate table command. So what is exactly the difference between a delete and a truncate? So there are certain differences. The first difference is if you use delete and you have the option to do a rollback, but whereas when you use truncate, you will not have an option to do a rollback. So once the table was truncated, that means that the entire data will be removed and you can't get back the data again. So that is the case, or that is the first difference. And number two, uh, while deletion, Oracle will make sure that even indexes are also getting updated. Because of that reason, delete operation will run a bit slower. But whereas when it comes to truncate operation, it will run faster. So this is one more difference that we have between delete and truncate. And finally, we have the option as drop table. Okay. So what I mean to say is, as we discussed earlier, whenever you do update to a table, index also will get updated. So for example, if you delete some rows from the table, at the same time index also will get updated. And usually what happens in real time is, because table and index both should get updated with this information, it will run slow. So the delete operation will run slow. Here you may not observe the difference because we just have two rows. But if you have lakhs of rows or crores of rows, then you will observe this delete operation will run slow. But whereas when it comes to truncate operation, it won't have direct impact on the index. So that's the reason it is going to work faster. So am I clear on that? Okay. So those are the two differences that we have. And then finally we have drop table command. So the moment you say drop table name, the table will be completely going out from the database. So yesterday I am talking about one point. I'm not sure. Did I talk about recycle bin? Okay. Yeah. So we have the recycle bin concept from 10G onwards. As I said, in 9i, if you drop the table, that will be removed permanently from the database. But whereas in 10G and 11G, 10G onwards, so even if you drop the table, that will go and sit and recycle bin. And if you want to see the content of recycle bin, you need to use this command show recycle bin, and it is going to show you which was the table, the original name, and etc, etc. So it will show you at what time you have dropped the table also. So more details. Yes, it is possible to restore the table from recycle bin, not through rollback, but we need to use a separate command for that. We will be discussing about this recycle bin more in our DBA course. So at that time I will show you everything. So that's how we have the things in place. So that is what we have in DDL and DML. So tomorrow we will be discussing about the select statements. So what type of select statements are there, and we will be talking about those things. So anyone is having questions before we close the call today? Okay. So create synonym. So just let me restore the table back. So anyway, you'll be using this command later, but I'm just trying to show you. So if you want to restore the table from recycle bin, this is the command you need to use. So you need to say flashback table name to before drop. Then the table will, and now if you say show recycle bin, you can see nothing is there in recycle bin because you already restored it. Now let's say I want to create a synonym, then I need to say create synonym name. For example, what I do is student personal information. Let's say I have taken the first three letters, and simply I need to say this. Oh, sorry. So we'll be writing like this. No. We have, oh sorry, it's for. I'm just confusing the things. For. Okay, so I'm going to, so this is how we are going to create. It's create synonym name for the the table name. So from now onwards, instead of saying select star from student personal information, you can do that. At the same time, you can also do select star from SPI, because SPI is indirectly referring to that table, student personal information.
So Pawan, for external users, we'll be giving the access for the synonym instead of table, if you have.
Yeah, exactly. So if you want to give access for other users, we will be giving that on the synonym. So user would be thinking that SPI is the table name, but that user would not know that the table name is something different. Okay. And Sanjay, what you mean by biodata? I couldn't able to get that. Okay, okay, got it. Yes, we can give any name. That's fine. Okay, and coming to the things, in synonym there will be two types of synonyms. One we call it as public synonym, and the other one we call it as private synonym. Now whatever I have created now is a private synonym, and what is the meaning of private synonym is the user who created only can access this synonym. For example, I have created this as a spot user, so you can see here. So that means only spot user can access this particular synonym, rest of the users would not be able to do that. But if I create a public synonym, then without giving permission, every user can start using that synonym. So if you create a private synonym, then permission should be there for other users. But if you create a public synonym, the name itself is telling you it is public. So every user will be able to use that particular synonym name. So again, which type of synonym we need to create and all, that depends on the business requirement. Most of the times this requirement will come from application team or the people who writes the code. Either you can call them as developers or application team. So they will be giving you the details on doing these activities. Of course, most of the times they would be creating the tables. They will do the insertion or they will do the you know all other things also, like creating the views, synonym, sequence and all. So rarely we would be doing that. And tomorrow we will see how to create a sequence and how to create a view, all those things. Okay, the thing here is I deleted all the rows, Sanjay. So if you go back, so here you can see, sorry, I said truncate table. So truncate table will delete all the rows. That's the reason here if you select it says no row selected. Fine. So let us meet tomorrow then at the same time, and we'll be discussing about the other objects. Okay. So till that, have a nice day and have a nice time ahead. So bye.